Hello, shall we start? Hello, shall we start? Okay, shall we start? Hello?
Yes, sir. Yes, sir.
Okay. Okay. I'll talk one of the paradigm. This is the just I'm reviewing what we have done in the last just before the break. Functional link network. The functional link network is also like a single layer network when you consider only original inputs and output. But what you are saying is that if you take only inputs, original inputs, and only single output without hidden layer, it cannot, network will not be trained. Then to overcome this problem, what we have done is that we have increased some inputs. My original inputs are only x1, x2, but my enhanced inputs are I took 5. You can take 10 also, your choice. There is no hard and fast rules, but only one rule is that the enhanced input should be more than the original inputs. Therefore, I consider 5. Then how to enhance? You can do multiplication, you can square, you can cube, you can fourth, or you can take trigonometric terms like sin x1, cos x1, or tan x1, okay, cot, etc., whatever it may be. Therefore, then, because what are the inputs now? Your original inputs plus enhanced inputs. My total inputs are total inputs equal to original inputs plus enhanced inputs. Enhanced inputs. Therefore, now we are using output layer as a sigmoidal function, and there is no input, there is no activation function for the input layer. Now, what algorithm says? Algorithm is same as that of the delta rule. What is that? The okay, the algorithm is what the first step. Consider original inputs. Original inputs. What are the original inputs? For example, x1, comma x2. Second step, enhance the original inputs. How to enhance? As I mentioned, x1 into x2, okay, comma, or you can take x1 square, or you can take x2 square, like that dot dot. The third step is that initialize the weights. Initialize the weights between input layer, and output layer. Okay. The fourth step of initializing, then what you have to do? Calculate output or I will write calculate output of the jth layer, jth node. That means output node. When you use sigmoidal activation function, first you calculate the net. Okay, what is the net? Your x1 w11 plus x2 w22 plus w21. Okay, like that. Then what is the output? Because you're using sigmoidal activation function, my output OJ is 1 by 1 plus e to the power of minus net j. Then fifth step, OK you are having, or OJ you are having. Yeah, then desired output is also you are having, just like what you have seen. Therefore, error you have to calculate. What is the error? Your OJ minus, sorry, your DJ minus OJ. Desired output minus calculated output. Next step. The sixth step is the sixth point. You have to update the bits because error is there. If error is more than 10 to the power, less than 10 to the power of 4, then you have to update the bits. How to update the bits? To update the bits, I should calculate delta WJ. What is the delta WJ? It is nothing but same. It is a continuous activation function we are using. Then I should use delta rule. We should use delta rule. What is the delta rule? If it is delta WJ, it is nothing but eta into, this is nothing but your DJ minus OJ into f dash of net j is a dash, f dash of net j into whole some input. Therefore, here eta into your dj minus oj, first order derivative of the sigmoidal function is nothing but oj into 1 minus oj into input. Therefore, then you have to update the bits. Seventh step, update the bits. Update the bits by using wji new equal to wji old plus this delta wji. Delta wj. Then continue the steps. Okay, once again, what you will do is that once again present the input, calculate the net, continue until error is small. Error is 10 to the power of minus 3 or 10 to the power of minus 2. Therefore, here here if you see this figure what we have drawn, this is my inputs total original plus enhanced, where initially is the weights, then we are getting the net. What is the net? X1 into W11, X2 into W21, X3. What is the X3? X1 into X2 into W31 like that. Then I get the net. After getting the net, I calculate the output. What is the output? The sigmoidal function we are using 1 by 1 plus e to the power of minus net j. Then here we are having, this is the supervisor, it is the desired output dj. Therefore, it is the oj. This is the oj. Therefore, our error is your dj minus oj. Therefore, when error is there, error you calculate, we have to update the bit. I'm going backward like that. In the back propagation from output layer to the hidden layer. Therefore, the expression we have seen, by using the expression, we have to calculate. If you want, I will take one simple example how to calculate with respect to, okay, example of FLL functional. Let us say I consider my inputs x1 equal to 1, x2 equal to 2. These are my original inputs. Now I want enhance. How can I enhance? As I mentioned, can multiply x1 into x2. That is 1 into 2 equal to 2. Or you can square x1 square 1, 1 square equal to 1, x2 square. Okay, it is 2 square, it is 4. Let us, I will take for simplicity only 3. I will enhance only 3. Therefore, here what is happening is that my inputs are, these are my original inputs. This is your x1 1, x2 2. I assume enhanced inputs are, this is your x1 dot x2. This is 2. This is x1 square. This is 1. This is your x2 square. It is 4. Now output I consider only one. It is having sigmoidal activation function. What this is the OJ. Then all are interconnected. Then calculate the net. You have to initialize the weights. Suppose this is W11, let us say minus 0.1. This is W2, 1, 2, 3, 4, 5. Is it? And W21, let us say plus 0.15. W31 plus 0.25. W31 minus 0.1. 51 minus 0.15 something. What is the net? 1 into minus 0.1 plus 2 into like that. I'll calculate the net. The net J. Then you calculate the output. What is the OJ? OJ is nothing but 1 by 1 plus e to the power of minus net J. Then corresponding this input, some desired output might have been given. That is your DJ. If you assume some DJ, it is a given value, some 1.5 or something, some value is given, then your error. As you see, error equal to your DJ minus OJ. Therefore, D we will know some 1.5, OJ you can calculate. Then update the weights. The weight expression is that WGA equal to your eta into your DJ minus OJ into F dash of net J. What is the F dash? Derivative OJ into 1 minus OJ into whole the input. Therefore, eta some value you will assume some 0.6 or 0.7. You know what is the DJ minus OJ. OJ value you will know, and 1 minus OJ you calculate, and input. Input is a vector. That is your what you have seen, your x1, x2, x1, x2, okay, x1 square, x, like that, what the corresponding values you substitute. You will get delta WJI. When you know the delta WJI, then again update the weights. That is to update the weight, this is the vector you will get. Therefore, to update the weights, same expression, whatever we are seeing, that is your W nu equal to WJI new equal to WJI old plus delta WJ. Therefore, old initial weights, it is also vector, plus it is also vector, then you will get WJI. Therefore, this is about how we will update the weights. And one more thing with respect to this neural network, this artificial neural network, we will also call knowledge-based system. Knowledge-based system. For example, if you see in the yesterday's PPT, what I was mentioning, if you see this AI based, second one, traditional, I cannot separate which is the program, which is the knowledge. Both are embedded together. But in case of AI based, we're having the program is separate and knowledge is separate. Where is the knowledge here? That's why you call neural network is knowledge based system. Where is the knowledge? So in the neural network, I will get the knowledge. Then program and knowledge, both they will interact. Then where is the knowledge? With respect to the neural networks, the knowledge is nothing but the stabilized weights. The weights which are every time we are updating, okay? After updating, what happens? Somewhere my weights will be stabilized after updating. Therefore, when knowledge-based system, the knowledge is nothing but what we'll call this knowledge is nothing but stabilized weights. Stabilized weights. Okay. This is about the how neural networks will work. And if you know, most of the time, suppose a load flow problem is there. So for example, everyone knows load flows. Hello? Whether you will know load flows or not. No one is answering. Are you able to hear? Hello? Hello, are you able to hear? No, someone of you respond. Are you able to hear or not? Hello? Anyone is there? Okay, if okay, I will stop with some one of the proverb because no one is answering at all. Okay, the last one. If you have hammer in your hand, everything looks like a nail. At least can you tell what is the meaning of this one? If you have hammer in your hand, everything looks like a nail.
Or reliable or dependent on something.
Hello, are you able to hear?
It's like what we call is if we have something like this, so we'll see that we are overconfident or over reliable on any particular activity. Like I have a hammer with me, so everything is like a nail. I can just cut it off like that. So we'll be over reliable or more
No,
reliable.
in this one, a proverb. In this one, if you
Oh.
have a hammer in your hand, everything looks like a nail. It indicates if you see a simple
Yeah, like
way.
over.
If you're having a hammer, suppose if you take the kids, the children who are coming to they're staying in the hostel for study. When they come to the home after one semester, come to the house, then what mother will do? She will prepare good food. That is, which the students have faced some difficulties in food in the hostel. Therefore, mother will cook the food which is very tasty and which is having lot of interest. The kid can have, he can take lot of food. Okay. Therefore, after coming from the hostel, the mother will prepare a good tasty food. It will take 2 days or 3 days. After that, no work. It's boring. Suppose in the house you have seen somewhere hammer, then what you'll take the hammer and you'll see the walls. On the wall, any hammer, any nail is coming, any nail is there. No nail. As in today, most of the houses on the walls, no nails. Therefore, then what he will do? He will check on whether any nail is there on the table or chair. Even when there is no nail, just because hammer is in his hand, just like he will nail it. The actual thing is that this is the actual meaning, but actual thing with respect to this neural network, suppose in you will know several paradigms of the neural network. Paradigms like algorithms are like back propagation algorithm, radial basis function, functional link network, algorithms are in your hand. Then what are the nails then? Nails will be problems. Suppose you are reading something or for your research, anything. Suppose people have done the problem with some numerical calculation. They use some numerical technique. They immediately will strike because already hammer is there. What is the hammer? Numerical, whatever the ANN paradigms. Then immediately will strike how to attack this problem by using a neural network. Therefore, that is your problems are the nails. Then you can hammer it or you can solve it by using the neural network. Therefore, this artificial intelligence, not only neural network, we are having certain deep learning, we are having machine learning algorithms. Okay. Therefore, if you read something, because we want to publish papers and all that, we want to produce something new. Therefore, already whatever existing, if you do, no one will publish the papers. Therefore, we should do something new. Sometimes what we have to do is that we have to hybridize. Hybridize means something. Suppose if you take, for example, everyone may be knowing evolutionary algorithms like genetic algorithm, PSO, particle swarm optimization, ant colony, honeybee. Okay, then you can neural network and evolution algorithms you can hybridize. If you hybridize, there is some reasoning should be required. Why you are hybridizing and what for you are hybridizing. And if you hybridize, your results will be much better than the individual algorithm. Suppose if you solve only with respect to neural network or only with respect to the one of the paradigm like PSO, okay, then compared with these two, hybridizing these two, then your results should be much better. Then people will appreciate. Then your paper will be published. Therefore, with this one, that is most of the from my part, that is if you basically what I will do is that hand calculations. Then you can go the program you can do by using the MATLAB or MATLAB toolbox, or you can write your own in Python. Then you can appreciate. Then without doing anything, we cannot appreciate. And one more thing, I will give you a simple example for this one. Suppose your load frequency problem is there. Because load frequency problem, we will have the single area system, two area system, etc. Therefore, in this two area system and single area system, most of the time uncontrolled single area system is there. Just suppose it's uncontrolled single area system. If you plot a graph between time versus change in frequency, because you're considering the fourth quadrant, because I'm considering my generation is less than demand plus losses. Suppose if consider generation is more than demand plus losses, your graph will come the first quadrant. Therefore, I'm considering this is the fourth quadrant. Therefore, uncontrolled case you will get a steady state error. There's no controller. But inherently it is having a proportional controller. Therefore, if you add an integral controller, what happens is that your error will be reduced, but some oscillations will be there. This is your PI controller. Therefore, to overcome the oscillation process, then I can use PID controller. PID. Therefore, in place of this conventional controller like PID controllers, then you can replace with a neuro controller. Therefore, when you are using this neuro controller, your result should be much better than this PID controller. Then that is something new. Or sometimes what people will do is that because we are having in the artificial intelligence, this neural network is there, like back propagation algorithm, plus some fuzzy logic is there. Therefore, they will hybridize. There is also toolbox also there, ANFIS, Adaptive Neuro Fuzzy Inference System. It is also a toolbox is available. Then you can use those things. There is something should be new. Then a papers can be published. Okay, I will stop here. If you're having any doubts, you can ask. Because most of the time you should do with your own hands, as it may be programming point of view or it may be in the calibrations point of view. Then you can appreciate. And one more buzzword is that more data, more accuracy in the neural network. Less data, less accurate. Suppose instead of taking 100 patterns, you take only 10 patterns to train the network. Okay, then what happens is that your accuracy suffers. You will get some results, but accuracy will not be there. Instead of 100 patterns, if you take 2000 patterns, then your accuracy is more. That is why a buzzword: more data, more accuracy; less data, less accuracy. Any doubt or no doubts? Okay, no doubts. Okay, if there are no doubts, I will stop here. Because if doubts are there, I will try to go on answering, because I'm interested to clarify more doubts. Because doubts also you can pose the questions when you work with the neural network. And there are several books are available in the library, or you can use on your Google search. Okay, a lot of material, but the material should be proper material should be required. And one more thing is the PPT which I presented. Okay, here in the PPT, I will ask Venkatamana to share that PPT. Okay, you can get more than what is the requirement. Okay, still another 5 minutes I will take. In the 5 minutes, what I want to talk is that, okay, within another 5 minutes I will stop. So far, whatever I covered, it comes under shallow neural networks. In this one, the neural network, whatever we covered, that is, we'll call shallow neural networks. Therefore, in the shallow neural networks, one limitation is there. What is the limitation? There is no feature extraction. There is no feature extraction. Therefore, to overcome this feature extraction, as people will starting deep learning. Deep learning or deep neural network, whatever it may be. Therefore, without the shallow neural networks, we cannot study. Therefore, this is the first prerequisite. If you want to deep learning, you want to study, we should know how the shallow neural network will work. In this deep learning, once again, we will have the paradigms like topology will be feed forward neural network as well as the recurrent neural network. Okay. Therefore, in this one, the most important thing is that people will use convolution neural network. In the feed forward neural network, CNN, convolution neural network. And one more thing, the recurrent neural network, we will have people will use LSTM, long short-term memory, long short-term memory. Therefore, most of the time, these algorithms, these deep learning algorithms, CNN, LSTM, people will used in the, as I mentioned in yesterday, some of the application that is autonomous cars, the driverless cars, etc. Therefore, based upon your applications, we can go through some of the algorithms. Okay, if there are no doubts, I will stop here and we can start once again tomorrow. That is the last day. Okay, thank you very much, all of you.
Thank you, sir. Thank you very much.